In this video, we'll dive into the world of multi-model databases. These are database systems that support multiple data models within a single database system. Let's get started. Multi-model databases are database systems designed to support multiple data models within a single integrated backend. This means you can store and query data in different formats using a single database engine. The benefit is that it eliminates the need for multiple specialized database systems. Multi-model databases provide a unified interface for various data representation needs. Some key characteristics of multi-model databases are the support for diverse data models like relational, document, graph, and key-value. They use a unified query language or multiple query interfaces. They also have consistent transaction and security models, and simplified data integration and management. Let's examine some core data models you'll find in multi-model databases, starting with the relational model. The relational model organizes data into tables with rows and columns. Relationships between tables are established using keys. Here's an example of a relational SQL statement. Create table users, ID integer primary key, name varchar 100, email varchar 100. Next is the document model, which stores data in flexible JSON-like documents. It is schema-free with nested structures for complex data. Here's an example of a document model: ID user 123, name John Doe, email john@example.com, address city New York. Finally, we have the graph model, which represents entities as nodes and relationships as edges. It is ideal for highly connected data and relationship queries. Here's an example of a graph query. Match user, relationship friends with friend user where user.name equals John return friend.name. Multi-model databases come with several key advantages. They offer data flexibility, allowing you to store different types of data in their most natural form. They reduce complexity by using a single system instead of multiple specialized databases. They also simplify data integration by providing a unified platform for diverse data types. They have consistent security in transactions, using a unified approach across data models. This leads to operational efficiency, with lower maintenance and operational costs. Now let's look at some common use cases for multi-model databases. One use case is a customer 360-degree view. This allows you to combine customer profile data, which can be a document, purchase history, which can be relational, and social connections, which can be a graph, in a unified platform. Another use case is fraud detection systems. Multi-model databases help to analyze transaction patterns that are relational alongside network connections that are graph, and user behavior that is in a document. Another use case is content management. Here, multi-model databases store structured metadata that is relational, unstructured content that is document, and content relationships that are graph. Another use case is Internet of Things applications. They help to manage device metadata, time series data, and device relationships. Let's explore some popular multi-model database systems. First up is ArangoDB, offered by ArangoDB Incorporated. It supports document, graph, and key-value data models. It is a native multi-model database with a unified query language called AQL, supporting document, graph, and key-value models in a single engine. It has features like unified AQL query language and distributed architecture, which is cluster. Next, we have ArangoDB, offered by SAP. It supports document, graph, key-value, and object data models. It is a multi-model NoSQL database that combines the power of graphs and the flexibility of documents while supporting SQL-like query language. Some features of ArangoDB are SQL-like query language and ACID transactions. Then we have CosmosDB, offered by Microsoft. It supports document, graph, key-value, and column data models. It is a globally distributed multi-model database service with support for multiple APIs including SQL, MongoDB, Cassandra, and Gremlin. Some features of CosmosDB are multiple API compatibility and global distribution. Finally, we have FaunaDB, offered by Fauna Incorporated. It supports document, relational, graph, and temporal data models. It is a serverless database with native GraphQL support that combines relational, document, graph, and temporal data models. Some of its features are FQL query language and serverless architecture. Let's delve into how querying works in multi-model databases. First, let's consider ArangoDB Query AQL. AQL allows querying across document and graph models in a single query. Here's an example. /find users and their friends, /keyword for user and users, /keyword filter user age greater than 30, /keyword let friends equals opening parenthesis, /keyword for friend and outbound user graph friendships, /keyword return friend.name, closing parenthesis, /keyword return opening curly brace name user.name, friends closing curly brace. Key features include combining document queries with graph traversals, using a SQL-like syntax familiar to developers, and supporting complex data transformations. Now let's explore the Cosmos DB multi-API approach. Cosmos DB supports multiple query languages through different APIs. Here's an example of a SQL API document model. /keyword select c.name, c.email, /keyword from customer C, /keyword where C type equals single quote premium single quote. Here is a Gremlin API graph model example. G.V opening parenthesis closing parenthesis, has label opening parenthesis single quote person single quote closing parenthesis, has opening parenthesis single quote name single quote comma single quote John single quote closing parenthesis, out opening parenthesis single quote knows single quote closing parenthesis, values opening parenthesis single quote name single quote closing parenthesis. Multi-API benefits include using familiar query languages for each model, leveraging existing code and expertise, and choosing the best API for each use case. While multi-model databases offer unified storage, query approaches vary between unified languages, like AQL and FQL, and multi-API approaches. Let's discuss some key challenges and best practices when working with multi-model databases. Some key challenges are performance optimization. Optimizing for multiple data models simultaneously can be complex. Another challenge is query complexity. Learning unified query languages or multiple APIs requires additional expertise. Another challenge is data modeling decisions. Determining which model to use for different parts of your data can be difficult. Another challenge is maturity and tooling. Some multi-model databases are less mature than specialized single-model systems. Now let's discuss some best practices. Start with clear use cases. Identify specific scenarios that benefit from multiple data models. Also have thoughtful data modeling. Choose the right model for each data component based on access patterns. Also ensure performance testing. Benchmark with realistic workloads across all data models. Finally, invest in training. Ensure your team understands the query languages and data modeling concepts. Consider starting with a pilot project to gain experience before migrating critical systems to a multi-model database. In summary, multi-model databases support multiple data models within a single integrated backend. They eliminate the need for multiple specialized databases and simplify data integration. Common models include document, graph, relational, and key value in various combinations. Leading systems include ArangoDB, OrientDB, Cosmos DB, and FaunaDB, each with different approaches. Now let's discuss the future trends in multi-model databases. First is artificial intelligence integration, with enhanced AI capabilities for automated data modeling and query optimization across different models. Next, global distribution with advanced multi-region capabilities with intelligent data placement based on model characteristics. Finally, expanded models with support for additional specialized models like time series, spatial, and vector databases for machine learning applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.